Hello, good afternoon all. Yesterday we have online MCQ test on chapter number 5, which is based on the thermal energy based non-conventional machining process. Right? Today we will discuss some of the MCQs related to this chapter and assignment questions based on this chapter and previous chapter, that is electrochemical energy processes, that we covered during this year. Whether screen is visible and my voice is audible, please reply to chat box. And also give the correct option whenever we are discussing the MCQ. Those are based on chapter number 5, that is the thermal energy based non-conventional processes. You may write your option in chat box also. Right? If orally it is not possible for you, but at least you have to give options that you think that was the correct option. Okay, we'll start with the now. Screen is visible. Screen is visible to all. Yes, reply please. Hello. Akshay Sate. Screen is visible. Yes or no? Dayanand. Rohit. Are you there? Okay, then. Thank you. The first MCQ from this chapter, that is a thermal energy based process. The work in electron beam machining is held in first option, that is a vacuum chamber. Second option, that is a dielectric medium. Third option, that is the electrolyte. And fourth option, that is a none of this. Means in case of electron beam machining process, workpiece is to be held. कशाची रिक्वायरमेंट असते इलेक्ट्रॉन बीम मशीनिंग प्रोसेस मध्ये वर्कपीस पुट करायला इलेक्ट्रोलाइट डायइलेक्ट्रिक मीडियम किंवा व्हॅक्यूम चेंबर E, that is the right correct answer. Vacuum chamber is essential. Good. Now next. In electron beam machining, EBM, as the electrons strike the workpiece, as electron strike the workpiece, First option, electrochemical etching is it is to be takes place. They get scattered. Mechanical erosion in workpiece takes place. Here kinetic energy is converted into heat energy. What will be the correct option? म्हणजे इलेक्ट्रॉन बीम मशीनिंग मध्ये जेव्हा इलेक्ट्रॉन वर्कपीसवर स्ट्राईक होतात तेव्हा काय होतं राईट पॅनल that is their kinetic energy is converted into heat. Good. The vacuum in electron beam machining chamber is in order of option A 10 to 1 to 10 to 2 torque, like 10 to 4 to 10 to 5, 10 to 6 to 7, 10 to 8 to 9. इलेक्ट्रॉन बीम मशीनिंग मध्ये जे काय व्हॅक्यूम आपण अचीव करतो क्रिएट करतो किती असला पाहिजे 10 to 1 given by Diana. Any other member those are present in this lecture? Diana has given us option A. Any other have any different option other than A? Mahesh, Prasad, Akash, Pooja, what will be the option? Sonali, I think it will be B. There is a 10 to 4 to 10 to 5. Okay. Thank you, Diana. Electron beam machine. Electron beam can machine conducting material, non-conducting material, or both of them. What will be the correct option? C. There is a both of them. Right. Other than Diana, please give the option. Might be it will be wrong or it will be correct. At least write the option which you feel it will be the correct. You have given the test based on this MCQ. Solving this MCQ means you are getting the answer for that quiz that you have solved yesterday. In electron beam machining, the order in which electron passes are emitted by filament cathode. The first option A, it is a diaphragm, anode, focusing lens, deflecting coil. Anode, diaphragm, focusing lens, deflecting coil. Focusing lens, anode, diaphragm, deflector coil. Deflector, anode, diaphragm, focusing lens. Option C, focusing lens, anode, diaphragm, and deflector coil. It's the correct option, that is a B, because from the anode electrons are to be generated. It will be passed to the diaphragm, and from the diaphragm it will be concentrated by using the focusing lens. Then it will be passed to the deflector. The vacuum in electron beam machining does not allow rapid deoxidation of incandescent filament. The rapid oxidation of incandescent filament. Both of them. The option. rapid oxidation of incandescent filament. I think none of them are B. Correct. Right, Sonali. Rapid deoxidation of incandescent filament. Yes, correct. A and B, electron and ion. In electron beam machining, beam current varies from 1 to 40, 10 to 50, 100 to 1 ampere, 100 microampere to 1 ampere, 100 to 1000 milliampere. The option is a C. Lower part of water injected torch in plasma cutting is made up of ceramic to avoid heat affected zone, smoke, formation of oxide, double R. Yes, what will be the correct option for the 9 number? Yes, anybody? D option given by the Anand. The significantly influenced by physical property of workpiece material, mechanical property of workpiece material, metallurgical property of workpiece material, and none of them. What will be the correct answer? The performance. Electron beam machining process performance कशामुळे असं होऊ शकतो? Physical property मुळे, mechanical property, metallurgical property of workpiece. The correct option. Yes, Pranit, what will be the correct option? Akash, Pranoti, nobody except none of them. It will be the I think thermal or electrical conductivity. That will be the main answer. Conductivity of the material that will be essential to have an effect on the process of electronation. Gas in plasma state becomes electrically conductive, electrically non-conductive, responsive to magnetism and chemically reaction. So it's the correct answer. Whatever the gas which are used in plasma arc machining, it must be initially it will be electrically conductive one. After that it will become a responsive to magnetism. Plasma arc cutting system uses AC or DC power supply. It will be a DC. Keep in mind that plasma arc machining वेळेस आपल्याला DC power supply हा गरजेचा आहे. Right. Zirconium is used as an electrode material in plasma arc cutting due to का वापरतो आपण झिर्कोनियम हे इलेक्ट्रोसाठी मटेरियल इन केस ऑफ प्लाझ्मा आर्क मशीन high thermal conductivity, low thermal conductivity, large heat capacity, high resistance to oxidation. What will be the correct answer? D, that is a high resistance to oxidation. Very nice, Diana. Mild steel plate cutting using plasma is commonly carried out using air plasma torch, oxygen injected torch, water injected torch, or none of them. Chandraprabha, give its answer. Pranoti, mild steel plate cutting using plasma is commonly carried out using. Think and give answer. That is the air plasma torch, right? Or oxygen injected, right? Mild steel plate cutting using plasma. एयर प्लाज्मा ऑक्सीजन इंजेक्टेड टॉर्च वाटर का काही विषय नाही. Just a minute. I am also confused. Here it will consist of oxygen, but for specific mild steel plate cutting, oxygen injected torch, I think it is essential. Mild steel plate cutting. So oxygen injected torch, it will be the correct answer. Okay, is it clear? The thickness of heat affected zone in plasma arc machining is in a range of zero point 0.1 to 0.6, 6 to 9, 0.75 to 5, none of them. It is a 0.75 to 0.5. 0.75 to 5, not 0.5. Nitrogen is used as a plasma gas in air plasma torch, oxygen injected torch. It will be in oxygen injected torch. Nitrogen as a plasma gas and oxygen it will be oxygen injected torch. Nitrogen gas it will be used as a plasma gas, right? Provide the oxidation of electrode and it will help to enhance here. Plasma gas it is coming from centrum, so cutting gas that is the N2, and oxygen it will be coming from the annular slots, those are provided in this torch. This part it is made up from ceramic. Whole assembly is called as a nozzle. In plasma arc cutting, transferred arc mode can machine only electrical conductive workpiece, only electrically non-conductive workpiece, both types. So it's the correct answer, that is a plasma arc cutting. It is a used for only electrical conductive workpiece. Machining of a electrically conductive workpiece only. The efficiency of plasma arc cutting when non-transferred arc is to be considered. Arc is to be used. Non-transferred. Non-transferred arc plasma arc cutting. It will be 65 to 75. That will be the correct answer. That is the A. Is the correct option. Next. Now, will be related with the laser beam machining. Some of them. The efficiency of laser beam machining system is about 3 to 5%, 13 to 15, 3 to 0.3 to 0.5, 30 to 50. Use the correct option. Laser beam machining. त्या प्रोसेसची इफिशियन्सी किती असते? D 30 to 50%. It will be 0.3 to 0.5% is the correct option. Okay, Chandra. Thank you. While drilling a deep hole by laser beam machining process, it is with reference to the top of the workpiece surface. It is a straight-sided, converging, diverging, none of this. Yes, use the correct option. B, that is a converging. Good. You can use LBM machining for glass machining of the glass. No, we cannot use laser beam machining for the machining of glass. The phenomenon of movement of an atom to a higher energy level is called absorption. That will be the correct answer. Keep in mind, when the atom is moving from lower level to higher energy level, that phenomenon is called as a absorption. Properties of laser beam is high monochromaticity, high degree of coherence, low monochromaticity, low degree of coherence. High monochromaticity, that is the answer given by the Diana. Any other who willing to give the answer? A and B. High degree of coherence, right? Solid state laser cannot be used for heavy duty work due to low intensity, low degree of coherence, poor thermal properties. Its correct option, that is a poor thermal property. In laser beam machining, the thickness of heat affected zone increases with increase in a feed rate, with a decrease in a feed rate. Correct option, that is with a decrease in a feed rate. Large aspect ratio hole can be drilled with a LBM. What is the aspect ratio? How it will? What is the formula? I think it is a diameter to length or length to diameter. The correct option for this large aspect ratio hole can be drilled with a laser beam machining. That will be the correct option. It is a true. The material removal mechanism for the laser beam machining is melting and vaporizing. Right. In all the thermal energy based processes, whatever the machining is to be carried out, it will be initiated by melting and it will be followed by vaporization depending upon the temperature that will be reached during that process. Which type of the material you are using for the work. This is the true answer. LBM with low divergence should be recommended for shallow hole drilling, large size hole drilling, deep hole drilling. Correct answer. Low divergence असेल तर by using laser beam we can produce large size hole by using laser beam. Next, mechanism of material removal in EVM now electron beam is due to mechanical erosion due to impact of high energy electrons, chemical etching by the high energy electrons, sputtering due to high energy electrons, melting and vaporization due to thermal effect of impingement of high energy. Correct option that is D. Good. Mechanism of material removal in laser beam machining is due to mechanical erosion. Yes, I got it. Electron beam. Mechanical erosion due to impact of high energy photon. Electron is replaced by photon. Electrochemical etching, melting and vaporization due to thermal effect of impingement of high energy laser beam particle. So its correct option that is the C. That is the melting and vaporization of thermal effect by the impingement of high energy laser beam. Okay, I request all of you to write your roll number in chat box for the attendance purpose. Write your roll number in chat box. किती फास्ट टाइप होते आता रोल नंबर टाका म्हणजे ऑप्शन द्या म्हणले की भीम काय महेश सुनील प्रणोती गीता yes sir eager to hear write your roll number huh? Is anybody remaining? अमोल पूजा सांगा तो ऑप्शन एखादा ओके generally electron beam gun is operated at atmospheric pressure at 1.2 bar above the atmosphere at 10 to 100 m torque pressure at 0.01 to 0.001 torque pressure. What will be the correct option? 0.01 to 0.001 torque. That was the unit of pressure. Laser beam is produced due to spontaneous emission, stimulated emission followed by spontaneous emission followed by spontaneous absorption leading to population inversion, and followed by stimulated emission. What will be the correct option? Okay, Chandra Prabha has given option D. Oh. Any other than Chandra Prabha? Please give the option. I will read the name. Puri Sahib, give the option. Yuvraj, Pooja Kamble, Kash, and Amol. Those names that I asked the name, they must have to give the option. The Dayanand has given D. Next, anybody? Okay, Amol D. Any other? Next option that is there. D is the correct option. Right. Good. Amol, Dayanand, Chandraprabha. List. You dare to write the option. Which of the following are correct components of ion beam? Vacuum chamber, voltage source, running, mode, tungsten, filament cathode, all of the mentioned. Right. This D. How does iron strike the workpiece in machining using iron beam machining? These are some of the MCQ based on iron beam. Oblique striking, normal incident striking, all of the mentioned, none of the mentioned. Yes, the correct option. Mahesh, Gaurav, write your option. Correct option that will be C. Oblique striking as well as normal incident striking. In this way, the iron will be striking the workpiece. Machining rates in iron beam machining depends on which the following factors: workpiece material type, iron type, incident angle, all of the mentioned. That is all of the mentioned. Amol as well as Chandra Prabha. Next, what is the value of voltage required for machining in iron beam machining? 1 kilovolt, 2 kilovolt, 3, 4 kilovolt. Write the correct option. What will be the correct option? Okay, A is the correct option. Now, what is the value of beam diameter that was used or obtained in a ion beam machine? 1 centimeter, 3, 5, 7. Akash, Pooja, Nikita, give the option. Akash, Nikita, and Pooja. That is the answer given by the Mahesh. Okay. Anybody? Akash. Okay. Pooja, are you there? Pooja Kamble, are you in lecture or in meeting? Hello? Unmute yourself, Pooja. Its option is a C. Okay. Hence, we are discussing near about 37 MCQs based on this thermal energy, based on thermal energy processes. Now, I request you to go through this MCQ booklet and I'll show you some of the competitive exam book or GATE exam book for the surplus MCQ. Then, as we discussed that, we must have to write the assignment, 1 page or 2 page assignment for each chapter. I think in last lecture, in the practical session, I think I will given that assignment question for overview of non-conventional material process, mechanical energy based on electrical energy non-conventional. Right? Yesterday we have a practical slot from 3:30 to 4:30, but because of a connectivity problem, I unable to conduct that practical. So in this lecture we have 15 minutes more in which we have to write the questions of the assignment. Those are based on chapter number 4, chemical and electrochemical based non-conventional machining process, and chapter number 5, that is the thermal energy based non-conventional machining. Write down the assignment number 4. First question: why surface finish obtained in case of chemical machining of alloy is poor? Second question: explain photochemical machining with the block diagram or flow diagram. Third one, briefly explain the working principle, equipment, process, capability or characteristics, and application of ECM, that's the electrochemical machining. Fourth, explain the mechanism of MRR, that is the metal remove rate, during ECG, that is the electrochemical grinding, and how it is different from ECM, that is the electrochemical. These are the four questions. You write their answers in short type within a one page or two pages. Write down this question for assignment number 4. Is it over? Now, assignment on question chapter number 5, unit number 5. Thermal energy based non-conventional material process. Explain laser beam machining in detail. Discuss electron beam machining. Explain plasma arc machining or ion beam machining in detail. Also, if possible, you write the difference instead of any questions out of these three questions, like the difference between BBM and the LBM that we have discussed in last lecture. Okay, have you written this question? So in this way, there will be one chapter remaining, Introduction to Coating Technology. You may write these two questions for the assignment. Number 6, explain physical or chemical vapor deposition coating technique. Second, discuss metallic coating in detail. So in this way, our thermal part, those are based on assignment that I have covered during this lecture. I will share a link for the submission of the assignment. Whether I have shared the link regarding the assignment since before? Hello? Unmute yourself and please tell me whether assignment submission link I have shared to you. पाठवली का अशी कुठली लिंक मी ज्याच्यामध्ये तुम्हाला असाइनमेंट सबमिट करा म्हणून सांगितलं? लास्ट टाइम मी सांगितलं होतं माझ्यामध्ये असाइनमेंट. राइट. ओके. I will share today. Right. So you have to write the assignment in one page or two page only. Write your roll number in right corner. Take its photo, image, convert it into PDF, and submit it by writing its name assignment number 1, 2, 3, 4, 5 by using the Google form that I will share. Right. You take 2 days so that everyone have to. I think last 15 days I have told about that we have to write the assignment up to number 3. We have to submit it for the marking scheme of the term. Remaining 3 that I have given today. So next 2 to 3 days you have to complete this 3 assignments. And everyone have to submit all 6 assignments at a time. When you register for the link for the submission of the assignment at that time, sequentially you have to submit assignment number 1, number 2, up to assignment number 6. Is it clear? Because it is a time consuming that to provide a separate link for each assignment. For each assignment, I have to prepare one separate link and share to you. Which is the better? Tell me. एकच लिंक पाठवून त्याच्यावरती सगळे 6 चे 6 असाइनमेंट पाठवतात. प्रत्येक असाइनमेंटसाठी एक सेपरेट लिंक प्रोव्हाइड करू. What do you feel better than? One link for all assignments or separate link for the separate assignment? Or no assignment? It is your opinion. Okay, thank you, Amol. I will send one link for all assignments, requesting all of you to write at least one page for each assignment. Right? Write assignment number 1, your name, your roll number, right, on right corner. I think this is sufficient from my side. If you have any query regarding this chapter, thermal energy based process, or from chapter number 1 to chapter number 5, we have time. You may ask me the query. I will try to give the answer for the query. I will try to solve it. Yes, anybody have any query? Otherwise, we will stop over here. In next lecture, we start with the last chapter, which is related to the introduction to the coating technology. गणेश एवढे उशीर असते का अटेंड? Okay, we will stop over here. Thank you very much. Yes, Suraj and Akshay, where are you? Jivraj Koi.